I'm now going to take a step back into the material section. Acumatica does a great job as it relates to different units of measure, how we buy and sell things. But as we get into process manufacturing, right, we have system, weight, and volume. So you can see here, because we understand density, by item, we could begin to go through the aspect of doing volume to weight conversions, volume to other conversions. From the aspect of those physical and chemical property links, right? How did we know? Every raw material, because of its cast number, etc., you're going to be able to define what are the physical characteristics of that item that will again relate to having the proper controls over the physical and chemical properties. I've already talked through how we could formulate things based upon weight and volume. Another key thing is units of measure. You could see that this is being inventoried in pounds. However, when we're formulating this, we actually want to formulate this in grams, right? We didn't want to be in a situation of some old time systems that a pound is a pound, so you have to put in 0.00001 in your formula because that's how many pounds it takes. So you see, we could have different units of measure and do those conversions. The other piece that Jessica pointed out is that process manufacturing is slightly different as it relates to losses. So depending upon the industry you're in, some cases this is overage, sometimes it's losses. It's alcohol, it's going to evaporate. So we could begin to say that even though this is what we need to our formula, how we're engineering this, we're going to need a little more because it's going to evaporate. In terms of these tolerances here, typical in some process manufacturing aspects, it's a little bit of a witch's brew, and either based upon the materials you're getting, in some cases the temperature, the conditions outside, you might allow people to vary the items that they're going to use. So we deal with those controls. Jessica alluded to the fact that we do deal with consumables, byproducts. Some of our clients have cans as they're beginning to scrape things out. They're putting it in cans. Those cans are really disposable cans, so those are consumables. So we get that from a cost aspect. We have byproducts. We could link tools. We could have overhead. And then kind of the speed demo is going back to something else that Jessica said is losses. Right, in process manufacturing, we might have a chemical that dissipates. Maybe it's a powder and it kind of dissipates, so we need more. That's the line level losses. We have yield, right? The reverse of yield is we have to plan. We're only going to achieve a 95% yield, so we want to plan losses for 5%. Loss constant is that particularly in some areas when it's a solid, in some cases when it's a liquid, you're piping things through. So again, that filler machine that Jessica showed you on that slide, every time they change over, they're going to lose a gallon or 2 gallons or 10 gallons. So again, if it's material, you could factor that into your base formula. So now when we're looking at the cost of these items, the cost of the item not only includes what we need from a pure formula aspect, but it considers all the losses and other factors. And you could see most process manufacturers at the end of the year, many of them have KPIs that say, what did I do in weight? What did I do with volume? So you could see how we're providing all of these. From a validation aspect, you're going to be able to see all the changes. This is constant throughout Acumatica in terms of events. And then what's the next piece, right? The next piece up is you have that formula, and then what do you do with it? You might just make it and put it in a container or a silo and later fill it, or eventually you're going to fill it. And you can see we're filling things into 5, 10, 250 gallon totes, all linked together. Why? Because therefore in one place, in one area, you're going to be able to control the formula. So if the formula changes, it changes in one place, and then we know how it's linked to all the finished goods that we're making. The bill of material for a finished good, again, I'm going to talk through this pretty quickly. It looks just like the bill formula we just looked at, right? There's process step. In this case, right, this is based upon what I'm doing to make that 5-gallon pail. It already assumes I've made the paint, so all I have to do to transform, add additional costs, which you'll see in a second, is I just need to pack it. What material I need to do? Fill level is a term that we've used within our group for a long time. That just says 5 gallons goes into a 5-gallon bucket. That's true, but particularly in some people with adhesives, etc., you're putting additives out there. So maybe in this 5-gallon pail, you're only putting 4.5 gallons because someone's going to put an additive on the top. So again, this is just saying what's going to go into it. What's the packing material? Again, consumables, byproducts, overhead could be added. This is where that formula becomes important, right? Because now what we could gauge is some of you might be private label people, might be doing some other things. Now we factor in what is the cost of the formula and what is the cost of translating that formula into a finished good.